All right, good morning. Today we are going to do some double angle formulas and also half angle formulas. So if you needed to take the sine of twice an angle, then unfortunately it's not just 2 sine x. There's a formula again, an identity that goes with this. So the sine of 2x is equal to 2 sine x. Pen's not working. 2 sine x cosine x. Okay, it's pretty straightforward. If you wondered why that works, you could actually do sine of 2x. Excuse me. Sine of 2x is the same thing as sine of x plus x, and then you could do the sum formula, which we learned yesterday, the cheer. So you would do sine, cosine, cosine, sine. So sine x cosine x plus cosine x sine x, and if you notice, those are exactly the same things. You can just switch these around if you wanted to, and you end up getting 2 sine cosine x, which is our identity right there. All right, so that's actually one that a lot of people remember. The cosine of 2x is the hard one. The reason why it's hard is because it actually has 3 identities in one. The cosine of 2x is equal to cosine squared x minus sine squared x. It's also equal to, see, that's written in both terms of cosine and sine. Then they also give it to you in terms of just cosine by using a Pythagorean identity. Yeah, my little guy's sick. By doing a Pythagorean identity, you can get rid of the sine squared, and you end up with 2 cosine squared x minus 1. And also, if you wanted to write it just in sine, it's 1 minus 2 sine squared x. You know, you probably could get away with just memorizing one of those, whichever one you want, because you can finagle it into any of the other ones. Okay, and the last one is tangent of 2x is 2 tan x over 1 minus tangent squared x. Okay, it's also equal to sine of 2x over cosine of 2x. Okay, those tangent ones are always equal to the sine over the cosine of whatever the angle is. So what do I need to memorize is what you're asking yourself. You need to know the sine of 2x and the cosine of 2x. And let's go for it. All right, we've got 3 problems to do. We are going to solve this, and whenever we're solving, remember we're going to do this from 0 to 2 pi. And then we're also going to prove number 2, and then number 3 we're going to simplify sine of 3x in terms of just sine x. Okay, so let's solve it. Here we go. So for this one, I have 2 cosine x plus sine of 2x. Whenever I see sine of a double angle like that, I want to rewrite that. So this is 2 cosine x plus 2 sine x cosine x equals 0. And from these, I notice that now I have it all set equal to 0, which is great. So why don't I factor out a 2 cosine x from both of them? So I factor a 2 cosine x to the front, and I'm left with 1 plus sine x. And so now I have 2 factors that I can set equal to 0 and solve individually. 2 cosine x equals 0, and 1 plus sine x could be 0. All right, you divide by 2. Where is cosine x equal to 0? Well, get out your trusty little unit circle here. So where's cosine equal to 0? Would be right here at this point 0, 1, and at this point 0, negative 1. So that would be at pi over 2 and 3 pi over 2. All right, over here, where's sine equal to negative 1? Well, sine is negative 1 over here at 3 pi over 2, which we already listed it, and so we don't need to list it twice. So you get 2 answers for that one. Okay, Number 2, we're going to prove that cosine of 2x is equal to, and there's a typo here. This would be really hard to prove because it's actually not true. Cosine of 2x is equal to 1 minus 2 sine squared x. I'm so glad I saw that because that would have been horrible to try and prove something that's not true. Well, we were given today that cosine of 2x is equal to 1 minus 2 sine squared x, but let's go ahead and prove it. So what we can do here is we can rewrite this. This is cosine of 2x is the same thing as cosine of x plus x. And yesterday we learned the cheer, of course, when you have the sum of an angle formula. It's cosine, cosine, sine, sine, sine. So cosine, cosine, sine, sine, sine. Change the sign in the middle. And then you end up getting cosine squared x minus sine squared x. And that was the one right here that you learned today. So that's cool. But now we got to get it into just terms of 1 minus 2 sine squared. So let's change this cosine squared to be, from its Pythagorean identity, cosine squared plus sine squared equals 1. Let's change it to 1 minus sine squared. And then I have another minus sine squared. And if I combine my sine squares together, I get 1 minus 2 sine squared will equal 1 minus 2 sine squared. Yay, pretty good. Okay. Now, this next problem is not fun. So I'm warning you. We'll see if you like it. Express 3x in terms of sine x. So right now it's got this 3 in there. We want to get rid of it. I don't know why we'd want to do that. Maybe calculus purposes later on, but if you need to take the derivative of sine 3x, you just use chain rule. So I don't know what the big deal is, but I'm going to stop complaining and just get to it. Here we go. Sine of 3x is the same thing as sine 2x plus x. And then I can use my sum of two angles formula. So sine, cosine, cosine, sine. So sine, cosine, plus cosine, sine. Okay. Now, I need it just in terms of sine x. So let's go ahead and right now this sine of 2x is bothering you and cosine of 2x should be bothering you. So let's rewrite those. The sine of 2x is 2 sine x cosine x. Okay, that's all I did was just replace this with this. And I still have a times cosine x next to it. Plus, now I need to get rid of this cosine 2x. And since I'm aiming for everything in terms of sine, that's the hard part about cosine of 2x. Like, which one do I use? There are 3 of them up here. Well, since I'm trying to get everything in terms of sine, I'm going to use 1 minus 2 sine squared x for that this time. So I get 1 minus 2 sine squared x times sine x. All right, so let's take a look. I've got a cosine times a cosine, so I have 2 sine x times cosine squared x, plus I can distribute this in sine x minus 2 sine cubed x. We're trying to get everything in terms of just sine x, and so let's go ahead and replace cosine squared x with 1 minus sine squared x using that Pythagorean identity we learned on the first day, plus sine x minus 2 sine cubed x. Whew, do you need me to pause a minute so you can catch up? It's a lot, I know. And then we'll take that 2 sine x and we'll distribute it in. So I'll get 2 sine x times 1 minus 2 sine squared x plus sine x minus 2 sine cubed x. Did I do that right? No. Do you see my mistake? Yeah? That should be a cubed right there. When I multiplied in, I forgot to cube that. It's because this was a squared right here. So 2 sine x times 1 is 2 sine x. 2 sine x times negative sine squared gives me negative 2 sine cubed. And then I have a plus the sine x minus 2 sine cubed. Okay, now let's combine our like terms and we're almost there. So we've got 2 sine x and another sine x gives me 3 sine x. And then I have negative 2 sine cubed and negative 2 sine cubed give me negative 4 sine cubed x. And now that would be your final answer. You're like, wait a minute, there's a cube there. That's okay. We want it all in terms of sine x. That is in terms of sine x. This is just 4 times sine x cubed. So we're fine. And that's it. All right. So we're about halfway there. Let's go to the next page. And, well, more than halfway. We only have 2 on here. These are the half angle formulas. We don't use them as much as double angle or sum of 2 angle formulas. I don't make you memorize these, which is nice. So let's write them down, and then I will give these to you on like like a paper, a formula sheet. So this is going to be plus or minus the square root of 1 minus cosine theta, or x, sorry, we're in terms of x. 1 minus cosine x over 2. Now it doesn't mean it has 2 answers because that plus and minus there. It means that you have to decide whether it's positive or negative depending on where you're at, what quadrant you're in. Same thing with cosine of x over 2. It's plus or minus 1 plus cosine x over 2. And tangent actually is a little bit nicer. It's sine of theta. I keep writing theta. It's sine of x over 1 plus cosine x. Or you can write that as 1 minus cosine x over sine x. You do not need to memorize any of these, okay? I'll give them all to you. But once again, tangent of x over 2 is still equal to sine of x over 2 divided by cosine of x over 2. Okay, we are going to find the exact value of the sine of 105 degrees. We're going to use a half angle formula for this. It would be, anyways, I'm not going to complain. I'm not a big fan of these half angle formulas. We're going to need it for sure in 5, but for 4, I would do this a totally different way. But they tell us to use it, so we're going to use it. So this is the sine of 105 degrees. We're going to use the half angle formula. So this is really the sine of 210 over 2. Okay? Now, if you notice, in our half angle formula, x is this up here. So this is x right here when I plug it into my formula for plus or minus the square root of 1 minus cosine x. X is going to be 210. So this is equal to. Now I have to decide, is this plus or minus? Well, 105, the sine of 105 is in quadrant 2, and we all know that sine is positive in quadrant 2. So this is going to be the positive square root. I don't need to write that, but just to show you. And this is 1 minus the cosine of 210 over 2. So let's evaluate the cosine of 210. Now I'm not a big fan of 210 because, it's like, where is 210? What angle is that? Well, it's 180 plus 30 more. So I'm in quadrant 3, so I know it's going to be negative. And it has a reference angle of 30 degrees. Well, over here, cosine is rad 3 over 2. So it's going to be negative rad 3 over 2. So I get the square root of 1 minus, so the cosine of 210 is rad 3 over 2 all over 2. Okay, we're going to simplify this a little bit. All right, I'm not going to make you rationalize it too much, but right now I have fractions inside of fractions and a radical, and I just can't live with that. So I'm going to multiply top and bottom by 2. And when I do that, I get the square root of 2 minus rad 3 over 4. And then we'll just do one more step. We'll split up top and bottom into their radicals. 2 minus rad 3, and then the square root of 4 is 2. That's going to be a fine answer. The book might not like that. Oh. Morning. You still sick?
I think so.
Yeah, Jack's staying home too. You're both sick.
I feel a lot better though.
Oh, good. All right, so 2 minus rad 3, so it's all underneath the square root, which is kind of gross and ugly, but that's the answer. Now, if you asked me to do this problem, I probably would have done, just on a little side note here, because I would give you the option on a test probably, if I wanted you to find the sine of 105, the exact answer. I mean, wouldn't you, I think you're with me on this, wouldn't you want to just do the sine of 60 degrees plus 45 and just cheer it out, because we're all a bunch of trig cheerleaders now, and you go sine, cosine, cosine, sine. I mean, that's what I would have done, and it would have gotten a lot nicer answer than that junk right there. Okay, enough rant over. Number 5, find all the solutions. All right, solutions. So we're on 0 to 2 pi again. And, whew, this one's a good one. All right, so here we go. Let's go to it. So we have 2 minus sine squared x equals, and take a look at what this is. This is 2 cosine of x over 2 squared. That's what that is. That's squared, you know, that's not how they write it, but that's what it's equal to. So we're going to do 2 times the cosine of x over 2 squared. Okay. Oh, I forgot this minus right here. Sorry about that. Okay, so we have 2 minus sine squared x equals, and now let's go ahead and replace cosine of x over 2. Well, the cosine of x over 2 is plus or minus 1 plus cosine x over 2. So, plus or minus the square root of 1 plus cosine x over 2, and we're going to square that. Because you might have been worried about that plus or minus there, but when we square it, it's just going to be positive. So we'll take care of that. All right, so then we get 2 minus sine squared x equals 2 times 1 plus cosine x over 2. So the square root and the squared cancel each other out. And now let's go ahead and simplify. So we've got 2 over 2. Yeah, he's sick too. You're both staying home. I'm staying home too. All right, so then we get 2 minus sine squared x equals 1 plus cosine x. All right, we're back to where we started when we started solving these things earlier last week. One like this was on your quiz too. So let's go ahead and replace this sine squared here. We're going to replace it with 1 minus cosine squared. And this is equal to 1 plus cosine. Hi. I'm sorry you're sick. Okay, so distribute the 1, and you get 2 minus 1 plus cosine squared x equals 1 plus cosine x. And we have squared, so we're going to bring everybody over to one side. Let's replace that with just 1. You subtract 1 from both sides, that's gone. And then bring the cosine x over and set it equal to 0. Ooh, we've done so much. All right, now factor out that cosine. Okay, And set each of your factors, we have two factors here and here, and set each of them equal to 0 and solve. So we want to find out where does cosine equal 0 and where does cosine equal 1. So you take it to the unit circle, and we did this one already today. Cosine is 0 at pi over 2 and 3 pi over 2. And cosine is 1 at 0. And you might ask, what about at 2 pi? Well, if you look back, our interval is restricted from 0 to 2 pi, and see how 0 is included, but 2 pi is not. So we'll just do 0. All right, that concludes my lesson on double and half angle formulas. I might do a bunch of the homework problems and post that onto my YouTube video. If you struggled with last night's homework, I might do some of those if I have time. I think I will. So look for that. I can send that out to you through Canvas. Maybe it would be better. Okay, sorry I'm not there today. Miss you guys. Bye.